So hello everyone. In the last session we have seen about the mathematical tools, and then we have seen the motion in a straight line, and now in the kinematics we have two parts that is left. That is, one is a circular motion, one is a projectile motion. So before going to the circular motion and projectile motion, it is very important that you should know about the vectors, because without that it is not possible for you to cover the circular motion and projectile motion. Then our two portions will be completed. One is a mathematical tool and one is a kinematics, and then we will go move toward the problem solving session, where we will take all the previous year questions of motion in or you can say kinematics part. Okay, so that our kinematics part will be finished, and then we will move to the laws of motion. Correct? So this is the flow is going to be. It is very structured and properly planned. Now so let us start with that. I hope my audio and video is clear and as well as visible to you. So let us start. So it is a very important session for you, because this is going to build a building blocks for a whole physics. So let us start with that. So our topic is basically, I told you that I have completed the vectors in lecture series. A proper lecture series is there. After one complete playlist of a vectors, you can watch that. Or if you have a less time and you want to complete the vectors and know the methods to solve the question, then you can directly come and see this video. That is for this video is for that only. Okay, if you don't want to go in detail. So the chapter is vectors. Okay, vectors is basically known as the heart of the physics, because you without vectors you can't solve any single question, because vectors is involved everywhere. So there are the two types of quantities we have. First is called as a scalar quantities. Okay, first is called as a scalar quantities, and second we have a vector quantity. So before that we have to see what is a scalar quantity. A scalar quantity means which has only magnitude but no direction. Need only magnitude. Okay, magnitude and no direction. And no direction. Second point, it's basically follows the algebra. You know, algebra means addition, subtraction, multiplication, division. Okay, follows the algebra. Whatever the algebraic rules are there. For example, we have mass. Okay, in the last chapter if you remember, we have seen speed. Correct? We have seen distance. Are you getting my point? So these are the scalar quantities. These are the defined as a scalar quantities. Correct? Any doubt? So this is the scalar quantity. Similarly, we will have a vector quantities also. Similarly, we have another type of quantity, that is vector quantities. Vector quantities means, first point, which need magnitude as well as direction also. Okay, magnitude as well as direction is required. Okay, magnitude as well as direction both are required. That is the first point. Second point, it follows the vector law of additions. It follows vector laws of vector law of addition. And third most important point, like what are the examples for this? First we have seen velocity, then we have seen acceleration, then we have seen displacement in the last chapter only. These are the different types of things you can say we have seen regarding the scalar and vector quantity. There are some other quantities are also there. For example, like we have a torr, we have torr. Okay, that we will see in the circular motion, or sorry, rotational motion, rigid body dynamics, where we will understand what is torque, what are the different types, how to measure the torque and everything. So this is the basic two types of quantities which we have in the physics, and where we classify the whole physics into two types. One is the physical quantities, means scalar and vector, and another is the calculation of their magnitude. Okay, but in the vector we are going to see what are the basic two important thing is the how to calculate the magnitude of the vectors and how to calculate the direction of the vector. That is the important thing, because by this only our whole physics is going to be depend. Clear? So let us start with this. So this is the two basic classification. Now the next important thing is that if there is some physical quantity is there, okay, when you can see that physical quantity is a vector, when it has a two things, first is a magnitude and second is a direction. But it doesn't matter that every physical quantity we have a magnitude as well as direction can behave as a vector quantity. It is not necessary. That is an important point which I am writing here. If it is a very important point for a question solving, if a physical quantities has a magnitude and as well as a direction, it does not mean that it will be a vector quantity. Okay, it is not necessary that it will be a vector quantity. That is a one important point. Second important point is important point is that for any physical quantity to become a vector quantity, it should follow the triangle law, vector law of additions. Okay, for physical quantity, that means physical PQ means physical quantity having direction along with satisfying the vector law of addition is a vector quantity. That is called as a vector quantity. Why I have told this point? Because if you know, we have a current has a magnitude as well as direction, but it is not a vector quantity. Okay, example is current I. It has magnitude as well as direction, but not a vector quantity. Okay, but not a vector quantity. There are some other types of also quantities similar to that. Current is also there, but we are not going, because that is going to be the out of scope for your syllabus. So just remember, current is one of the quantity which has a magnitude as well as direction, but it is not a vector quantity. It is something called as a tensor quantities. Tensor quantity. But if someone, suppose in the option they have given you a scalar and vector, then you will mark it as a vector. Until and unless they haven't mentioned anything about the tensor quantity, then till then you will mark it as you will consider it as a scalar quantity. Because why? Because it is not follow the vector law of addition, or you can say whatever the vector law of, there are the different types of vector law of additions are there: addition, subtraction, parallelogram law of addition, triangle law of addition, polygon law of addition. These are the law which it doesn't follow. Clear? Now next thing is the symbolic representation of vector. How you represent the vector, how the vector look like. Representation of vectors. If we talk about the representation of vectors, the first thing is we have a first thing called as a symbolic method. What do you mean by symbolic method? Symbolic method means suppose I have to write some vector. So I will just write it like this. Suppose the A vector and I will put it like this. This is a symbolic representation. This representation is called as a symbolic representation. This representation is a symbolic representation. Where what we do, where we simply put a circle. Whatever the symbol we have, we simply put a, or leave it like this. Simply the alphabet with the arrow mark on the top of the letter, or you can say alphabet, that is defined as a symbolic method. This is how we represent a vector in the symbolic form. Second method we have is the graphical method. Okay, second is graphical method. Now what is graphical method? In graphical method, suppose I have a vector, how I will represent it. The representation is very simple. It's like an arrow where this thing is called as a tail. Okay, tail means behind point, and this is called as a head. Arrow is called as a head. So this is tail, this is head, means vector is going from here to here, so that is the direction. Okay, and the length, this is the length, that is equal to magnitude, because there are the two things for a vector, na, direction and magnitude. Direction you get from the head to tail, so direction is tail to head or head to tail, whatever you say, but length is from the length tell us about the magnitude. So if suppose I have a two vectors, one vector is like this and one vector is like this. Suppose this length is L1 and this length is L2. Okay, what I can say my L2 is greater than L1. So this vector, suppose vector A is there and this is vector B. So I can say directly, sir, the magnitude of vector A is greater than magnitude of vector B, because length denote about the magnitude. Okay, length denote about the magnitude, that is directly tell us about the magnitude of the vector. Clear? So this is about the representation of a vectors. There are the two representation, one is a symbolic representation and one is called as a graphical method or graphical representation. Now the next is the type of vectors. I hope till here everything is clear. Now the next thing is type of vectors. Types of vectors. Now what are the types of vector? Let us see that. So there are the different types, there are the different classification of vectors. First classification, that is called as a parallel classification, or you can say parallel vectors. That is called as a parallel vectors. Now what is parallel vector? Parallel vector means the vector which having a same sense of direction, but their magnitude is not required to be same, but their direction will be same. Okay, the vectors whose direction is same. Okay, that is called as a parallel vector. Clear? Next vector is called as a equal vector. The vector which has a same direction as well as same magnitude, means the direction as well as magnitude both are same. That is called as a equal vector. Okay, remember that from here I can say all equal vectors are parallel vectors, but all parallel vectors are not equal, are not equal vectors. Correct? So I can say my equal vector is a superset of a, or you can say it is a father of a parallel vector. Simple. Okay. Next we have a anti parallel vector. What is anti parallel vector? Anti parallel vector means vector having a opposite direction. Okay, the vector having a opposite direction. The vectors having, okay, opposite direction. Opposite direction. What I am trying to say, suppose there is a one vector in this direction, correct, and another vector is in opposite direction, so that is called as a anti-parallel vector. This is a vector and this is b vector, so their direction is opposite, correct, so that is called as an anti-parallel vector. Clear? Next vector, we have a opposite vector. Till then you note down the things. Let me give you a time so that you can note down. Just note down till here. Completed? Okay. So opposite vector means the vector which has opposite direction and same magnitude. Means the magnitude will be same but the direction is opposite. Same magnitude. Correct? That is called as a opposite vector. Next is perpendicular vector. What is perpendicular vector? The vectors which are 90 degree to each other. Vectors which are -90 degree to each other. Next is that is null vector. Means the vectors the vector whose magnitude is 0 and direction is anything. Okay, direction is, you can say, arbitrary or anything. Better to say anything, that will be more easier for me to write. Okay, that is called as a null vector, like this. Null vector, simple. Are you getting my point? So these are the some classifications. Some more classifications are also there. Okay, magnitude is 1, that is called as a unit vector. Means the vector whose magnitude is 1 is called as a unit vector. Okay, the vector whose magnitude is 1 is called as a unit vector. Correct? The vector whose magnitude is 1 is called as a unit vector. Clear? Next thing is, unit vector is represented as a cap, which can be written as vector, whatever the vector we have, just divided with its magnitude. How to find the magnitude, I will tell you the method, but till now you remember, whatever the unit vector you have to find, just take that vector, divide it with magnitude. Here, next we have axial vector. Axial vector. What is axial vector? Okay, vector. Okay, vector acting along the axis of rotation. That is vector which is along the axis of rotation. Axis of rotation. Clear? There is suppose this is the axis of rotation, correct? So if you take a lot of vectors are there, for example, like angular displacement. Okay, this you will see in the rigid body dynamics. Okay, angular displacement. I told you one example also, torque. Okay, torque and what angular acceleration. Angular acceleration. So these are the some different types of axial vectors are there, correct? Next we have okay. Next vector we have a first note it down till here. I hope you are getting what are the there are small definitions only. Okay. Yeah. So 9, that is concurrent. Sorry. That is concurrent vectors. Concurrent vectors means vector that are originating from the same point. The vectors which are originating from same point. Which are originating from same point, correct? Next is coplanar vector. Coplanar vector means the vector which are lie in the same plane. Vectors which are lie in same plane, correct? They are called as a coplanar vector. That vectors are called as a coplanar vector. So these are the definitions of the different types of vectors. Okay, clear? So these are the different types of vectors. I hope it is clear. I hope you are clear with the classification of the different types of vectors. Clear? Okay. So let's proceed further. Next thing is the sum node. Okay, whatever the node points I am giving, it is very important. Okay, first thing, a vector can be shifted parallel to it itself. Means suppose I have a vector like this, I can shift this vector parallelly to anywhere. What I am trying to say, suppose I have this vector. Okay, now my thing is that I can shift this vector here like this parallelly, here like this parallelly, okay, like this parallelly, like this parallelly. Okay, means I can shift it parallelly. Okay, I cannot do like this. Okay, I will shift it here or here, anything not like this. I can shift only the parallelly. Parallel shifting is allowed. Okay, this vector won't change, so that is called as a parallel shifting. So first node point is, we can shift the vectors parallelly in the space. That is the first thing. We can shift the we can shift the vectors parallelly in the space. Okay, that is the first point. Second point is, if the vector is rotated, if the vector is rotated by any any angle by any angle other than 2 n pi, then that vector will change. Okay, the vector won't remain same, it will change. Vector will not remain same, it will change. Means you cannot rotate the vector. If you want to rotate it and you want it that it should be remain same, then you have to rotate it with the multiple of 2 pi. Okay, where n is an integer, obviously. N is what? N is 0, 1, 2, like this, integer. Clear? These are the some important points. Third point is, what is the third point? Okay, sorry. Maximum number of vectors with equal magnitude give 0 is 2. Means there are the only maximum 2 vectors that can be possible which having an equal magnitude that can give 0. How? Like this. If they are in opposite direction and equal magnitude, they will automatically make it 0. This is vector A, this is vector B. Correct? So they are in equal magnitude but opposite direction, so they will automatically give 0. Clear? I hope you understand the concepts, what I am trying to say. Now the next thing is angle between the vectors. Okay, sorry. Okay, angle between the vectors. Now what is angle between the vectors? Let us see this. What is about the angle between the vectors? Okay, See, whenever we have to find the angle between the two vector, either we have to see the angle between tail to tail or head to head. That is a simple logic. Okay, tail to tail or head to head. Okay, so angle between, first you have to remember this line. The angle between the vector is angle between their head to head or tail to tail. Now let us see this. Suppose this is a one vector, this is a one vector, then this is another vector, and this is another vector. So this angle is theta, this angle is theta. So this is called as an angle between the two vectors. Okay, this is angle theta, this is angle theta. This theta is a angle. Suppose this is vector A and this is a vector B. This is a vector A, this is a vector B. So this theta is a angle between A vector and B vector. So first of all, you should know how to find the angle. Okay, first of all, you should know that is how to find the angle. Clear? That is very clear to you. That should be very much clear to you how to see the angle between the two vectors. You will see the formula. There is a formula. The formula is very simple. Okay, but before going to that formula, you should know how to find the angle. For seeing the angle, you have to see either the angle between the tail to tail or head to head. That is a simple logic I am trying to explain. Clear? Next thing is the addition of vectors. Sorry. Next thing is the addition of vectors. How to add the two vectors? Addition of vectors. So let us see for the addition of vectors. If you talk about the addition of vector, the first law is the triangle law of addition. Okay. Okay, what is a triangle law of addition? Just I try to explain you in simple manner. Suppose this is a triangle. Okay, suppose this is a triangle, or let me draw it only for more. Suppose this is a something like this. Okay, and suppose this is my vector A, this is my vector B, this is my vector. No need to think of anything, because lot of student thinks, sir, which has to be plus, which has to be minus, which is come to left hand side, which is no need. Just move in a loop. This direction A vector, right? This is moving like this, B vector. But see, this direction is opposite now, so write minus E vector equal to 0. You will get the expression A vector plus B vector is equal to C vector. That is the answer. Okay, just what you have to do, move in a loop. This is a same direction, this is also same, this is opposite, this should come like this, but it is opposite now, just like a minus sign. Simple. This is a triangle law of addition. Finished. No need to remember anything. People used to tell a lot of things, no need of that thing. Simple rule. What I am telling is very simple. Second is you can say parallel forgive me for the spellings. Okay, parallelogram law of addition. This is also very simple. What you have to do? Very simple. It is also very simple. Suppose this is my parallelogram. Okay, suppose this is my B vector, correct? This is my A vector, correct? Suppose this is a diagonal. There will be two diagonals will be there. Suppose I am talking about this diagonal, correct? Okay, so my question is very simple. My question is very simple to you. Like if these are the two vectors, I can project, what is the rule I know? I can parallelly shift the vector, correct? So if this is a vector, B vector, I can parallelly shift, I can say this is also a B vector. Similarly, I can parallelly shift and I can say this is also a vector. Okay. So if it is like this, and if the arrow, if this arrow is moving something like this, okay, suppose, then in that case, can you tell me what in first loop, if I apply in the first loop, then what is this C vector? The C vector, what is going to be? See, if I apply the in first loop, this will be something like this: B vector plus A vector minus C vector is equal to 0. So from here you get C vector is equal to A vector plus B vector. Simple. That is a parallelogram law of addition. Okay. Parallelogram law of addition. Simple. No need of stress. Basically, if you know how to write a KVL, you can say KVL only, and you can directly tell me the answer. Okay. No need to even study this law of additions. They are just time waste. Just you have to apply the KVL. Okay. You should know how to link the physics. If you know how to link the each chapter with each, then it is very easy to remember the few things. Okay. Okay. And last rule is, if you want, you can note it down. That is polygon law of addition. Polygon law of addition. That is last rule. That is very simple. What is this rule state? 1 minute. Sorry. Yeah, parallelogram law of addition. It's very simple. Polygon law of addition. It's very simple. You can take any polygons. Okay. Let us take any polygon. Okay. Sorry. Let me draw it. Something like this. And suppose this is vector A, this is vector B, this is vector C, this is vector D, this is vector E, this is vector B, this is vector G. If I ask you to move like this and write the thing, can you write me? Yes, I can simply write, sir, vector A plus vector B plus vector C plus vector D plus vector E plus vector F plus vector G plus vector G is equal to 0 vector. Simple. Simple rule. No need of thinking anything, no need to do anything. Just you remember the concept, you have applied it. Simple rule. Okay, simple way. You can simply write it. Clear? So that is the different law of additions. Now the next is out magnitude of a vector. We have seen how to find the direction. Now the next is how to find the magnitude of vector. What I am trying to say, suppose there are the two vectors are there. Okay. Suppose there is a one vector like this, and suppose there is another vector like this. Okay. And suppose the angle between the vector is theta. Okay. This is my A vector and this is my B vector. Sorry. This is my B vector. And suppose the resultant of this vector is this phi. Okay, my question is very simple. First, this resultant vector is suppose C. First, my question is, what is that magnitude of C vector? The magnitude of the C vector is simply given as mod of A square into mod of b square plus 2 times of mod of a into mod of b vector into cos theta. That is the first thing. Second thing, what is the angle phi? This angle phi is given as tan phi is equal to, remember it is mod of b vector into sin theta divided by mod of a vector, sorry, mod of a vector plus mod of b vector into cos theta. So that is a tan phi. So these are the two important concepts, like basically how to find the magnitude of the vector if we have these things. Okay, if you have given a vectors and angle between them is also given, this is how you can find the magnitude of the resultant vector. Correct? That is the first thing. Second thing, some important notes. What is the note? Suppose first case, if theta is equal to 0 degree, then mod of c vector is equal to how much? What is the mod of c? Then mod of c vector is simply become mod of a vector plus mod of b vector. Correct? Second thing, if suppose theta is equal to 90 degree, then mod of c vector will become how much? Root over of mod of a vector ka square by mod of b vector ka. If theta is equal to 180 degree, then mod of c vector will become mod of a vector minus mod of b vector, means difference of the two vector. Okay, difference of the two vectors. So this is called as a maximum value. This is maximum and this is minimum. This is maximum and this is minimum. So I can say my c vector will always be present between these two vectors. Mod of vector, sorry, mod of vector a plus mod of vector b to mod of vector a minus mod of vector. It will be always present between these two vectors. Okay, that is the first thing. Second thing which you can take is okay, that much is sufficient. Yeah, that much is sufficient. No need to that. I can tell you in the dot product, not here. Okay, in dot product I will tell you how to find the angle, because we have seen one topic now that there is an angle between the vectors. Okay, so how to find the angle, that we will see in the dot product. Second important thing is the some special cases, which is very much familiar in the electrostat used to come. Okay, special cases, and some lot of time we will see. Okay, they will give you suppose if my vector a magnitude, vector b magnitude, both are same, that is f. Okay, then remember mod of c vector will be equal to, that is resultant vector is equal to, its value is fixed, that is 2 times of f cos theta by 2. And now there are three cases when theta is equal to 0 degree, that is 2f. Second case when theta is equal to 180 degree, that is 0. And third case is when theta is equal to 90 degree. Okay, 90 degree, that is root 2f. Correct? So these are the some important cases are there. Okay, one more thing, or let us remove this. Basically this is the first thing this much you should know. Okay, I want to explain the difference of the vector, but I'm trying to explain it with the polygon, but okay, let me explain in the another manner. Suppose I have to do the subtraction. Okay, let me, with hexagon it is easier to explain. Okay, okay, that is subtraction of vector. Let me try to explain in another manner. Suppose I want to subtract two vectors. Okay, and suppose the vector is like this. One is vector A, one is vector B. This is my vector A, this is my vector B and theta, and I want to find, suppose I want to find vector C, which is defined as vector A minus vector B. Now my question is that how will you do that? Means how will you try to find vector A minus vector B? See, direction you can find, direction is not important, but the important thing is that magnitude. What about the magnitude? Will the magnitude will be the same formula we have to apply? No, here there will be change in the formula, and the formula will be mod of A vector square mod of B vector square minus 2 mod of A vector into mod of B vector into cos theta. There is a logic why this minus sign is coming here, but as I'm not able to draw the hexagon properly, so just leave it. Just you remember that whenever I have to find the difference of the two vectors, and in that case the magnitude will be given that like this. Only you have to replace the plus sign in the previous formula by minus sign. Clear? Just note it down. Similarly, here also you can see the different cases if you want. Okay, here also, like here also, if I ask you, suppose in this case, if suppose I ask you that is mod of A vector is equal to mod of B vector is equal to some f, and then in that case, then same thing, mod of C vector will be same thing, 2f into, but now it is sine theta by 2. So again theta is equal to 0 degree, then mod of C vector will be what? Then in that case the resultant will be what? 0. 90 degree, then it is root 2f, and the last is 180 degree. That is how much? That is 2f. So this going to be the case. Okay, the case will be like this. Clear? So like you can remember it as this much. This is very important for you. This you can leave if you want. That is not important. Okay, that is very normal. Clear? Any doubt till here? Okay. Next thing is there is a very special cases are there. Special cases, another special cases, like first case, suppose there is one vector like this, there is another vector like this. Okay, then we have another case, suppose this is a one vector, this is another vector. Okay, wait a minute, and this is another vector, and one more case is there. One more vector, okay. So if this is a case, then first is, suppose this angle is 180 degree and 120 degree, 120 degree, 120 degree, and these all angles are 90 degree, 90 degree, 90 degree, and 90 degree. The thing is that all vectors are same. Okay, if you see here, all the vectors are same. All the vectors are same. Then in this three combination the net resultant vector is always 0. These are the three important combination in which you will get the net resultant vector is always 0. If you find in this, this or this, these are the three important cases. Okay, these are the three important cases where you will get the net resultant vector always equal to 0. Doesn't matter what you are taking, it will be always 0. Means always. Okay, clear? Any doubt? So till here we have seen the different cases. We have seen how to find the magnitude and all these cases. Now the next thing we want to see is the resolution of the vector. That is very important. Resolution of vectors. What is the resolution of vector? Let us see. Suppose I have a vector. Suppose this is my x coordinate first. Okay. And suppose this is my y coordinate. Correct. And suppose there is a one vector is there. This vector magnitude is a and this angle is theta. This is my x, this is my y. In x, you know the vector is position vector is I, y, you know the position vector is j. That you know. Okay, because if I go to explain that also, then it will become a complete course, not a crash course. Okay, I consider that you at least know that much. What do you mean by projection? Projection means taking the component along some another vector. Okay, projection means taking component along some another vector. So in 2D, if I am asking, this is in 2D. In 2D, if suppose I am 2D, I want to find the projection. If this is A and this is this distance I want to find. So by trigonometry, what will be the distance? If you apply the trigonometry, you will get the distance is equal to mod A cos theta. Similarly, if you apply this trigonometry here, you will get this distance is mod A sin theta. So I can say my vector A can be written as, okay, one is A cos theta magnitude in I cap direction. I cap means along x. I cap means, what is I cap? That is along x, plus mod of A into sin theta in j cap direction. And that can be written as, this is written as A vector along x. This is written as A vector along y. Correct? So from here you can get theta, tan theta by using AY divided by AX. So that is how you have to take the component. I can give you any combination of, you can see how to take the component. Okay. Next thing is, suppose in 3D, this is in 2D. Okay. In 3D, how will you do? In 3D, we have a formula. In 3D space. If it is in 3D space, how will you do? Let us see. Suppose I am talking about 3D, means suppose this is my x, this is my y, and this is going to be z. And suppose another thing that I have a sum vector. Okay, I have a sum vector like this, and suppose this angle is alpha with the x-axis, beta with the y-axis, and gamma with the z-axis. Okay, component is I cap, this is j cap, and this is k cap. Correct? alpha, beta, gamma, all three angles are given. Correct? Alpha, beta, gamma, all three angles are given like this. All three angles are given like this. Now, how will you take the component and how will you write it? It is very simple. See, I know that a vector can be written as, suppose if it is a vector, one thing I know, I can write it as ax I cap, ay j cap, and az k cap. If I understand the pattern from the 2D, I can see that, okay sir, it is written like this. So here only we will get one extra term, that is az. Now what is the important thing we have to know? That is what is ax, what is ay, what is az. So that is a directly given as ax is equal to mod of a vector into cos alpha. Similarly, ay is equal to mod of a vector into cos beta, and az is equal to mod of a vector is equal to cos gamma, and this is called as a direction cosines. Direction cosine, and from here we have a one relation, that is cos square alpha, cos square beta, cos square gamma, that is equal to 1. Or you can break it into sin square alpha, sin square beta, sin square gamma is equal to 2. So this is the important thing. And second thing is, how will you find the mod of a? Mod of a is very simple. Just take the square, ax square, ay square, az square, because they are magnitude only. Just do that and you will get that is the magnitude of the vector. You have to take I component square, j component x square, k component square. Simple. That is the magnitude of a vector. So this is how you take the projection in 2D as well as in 3D. You should know how to take the projection in 2D as well as in the 3D. So this is how we used to take. Clear? Now the next thing after that is the important part of a vectors is the dot product and cross product, where we understand how to take the how to find the angle also. Where we will understand how to find the angle also. So first we have a dot product. First we will have a dot product. So if you see about the dot product, first thing, how we have dot product is a defined as, it is a scalar product. It is defined as a scalar product. Means it is a scalar quantity. If it is a scalar product, means it is a scalar quantity. How we have defined the dot product? That is, if suppose we have a two vectors, vector A, and there is another vector, that is vector B, and the angle between them is theta. This is my vector A, this is my vector B, and the angle between them is theta. The dot product of the vector, these two vector, dot product of these two vector, that is written as A dot B vector is equal to define as mod of A vector into mod of B vector into mod of B vector into cos theta, where theta is what? Theta is the angle between these two vectors. So from here we got cos theta is equal to A vector dot B vector divided by mod of A vector into mod of B vector. Means the angle between the two vectors is found through the dot product, and the cos theta is defined as a, that is the angle theta, where theta is the angle between the two vectors, is A dot B divided by mod of A into mod of B. So if my theta is less than 90 degree, then what does it mean? It means both my vector A and vector B are positive. Dot product of A dot B vector are, A dot B is positive. If theta is greater than 90 degree, that means A dot B vector is negative. And if theta is equal to 90 degree, then A dot B is 0. Means they are perpendicular to each other. Clear thing? So that is how we have to find the angle between the two vectors. And remember that dot of I dot I dot is 1, k dot is 1, j dot is 1. Other combinations 0. Other combinations 0. Whatever other combination you will take, you will get 0. So suppose if I have a vector A as ax I cap plus ay j cap and plus az k cap. Similarly, we have a b vector is equal to bx I cap, by j cap and bz k cap. The question is very simple. You have to find a dot b vector. Then how will you do? Just do multiply this I component with I component and j and add it, and y component with y component. That is a dot b vector. So this is how we can find the dot product of a two vector, and from there we have understand how to calculate the angle between the two vectors. Now the next important point is, after this we have a cross product. What is cross product? Cross product is simply defined as a vector product. It is a vector product. Is defined as a vector product. Vector product means, like, suppose if I have a suppose I have a two vectors. Okay, suppose this is a some plane. This is a one plane. This is another plane. Suppose one vector is vector A in this plane. Another vector is vector B in this plane. Correct? And the angle between them is theta. Correct? This is the thing. Then my question is that it is a vector product. That means it will have a magnitude as well as a direction. Then the question arises how to find the magnitude and how to find the direction. So first we will understand how to find the direction. For finding the direction, for direction, use right hand. Use right hand rule. Now what is right hand rule? You have to keep the hand of one vector, you have to keep your hand in the direction of one vector and curl it toward the another vector. Then the thumb give the direction of a resultant vector. Let us see some example, then you will understand. Suppose we have a vector like this. Suppose a vector, dot means inside and cross means outside. Cross means inside and dot means outside. So we have one vector A that is inside and the B vector is like this. Now what is the direction of this A cross B? A cross B means we will write it like this. A vector cross B vector, which is defined as, first of all let me tell what is the definition. Mod of A vector into mod of B vector into sine theta into n cap. N cap is a unit vector along C, along resultant vector. That is a unit vector. Okay, that is a direction. Okay, eta is a unit vector. Okay, unit vector. So how to find? See, first you have to keep your you can say thumb, or you can say fingers in the direction of A vector. A cross B we have to find, so A is inside. Then what you have to do, you have to curl toward the another vector. A is inside, curl toward B. A cross B, A cross B, A cross B, the direction is like this. So you will get the C vector is like this. Clear? Similarly, suppose you can take, this is my A vector and this is my B vector, and the angle between them is theta. Okay, so what you have to do, A, this is my plane, it is A cross B. You are getting thumb in upward direction, so this is my C vector. Okay, this is my C vector. So what you can see from here, that is C vector is, that is C, that is resultant vector, resultant vector is perpendicular to both A vector and B vector. So I can see C dot A should be equal to C dot B, they both should be equal to 0. That is a one important point. So first thing, how to find the direction. Second thing, how to find the magnitude. Now how to find the magnitude? For magnitude, simple formula is there, mod of A vector into mod of B vector into sine theta. And how to find the theta? By using the angle between the two vectors, that is cos theta is equal to cos theta is equal to A dot B divided by mod of A vector into mod of B vector. Now there are some formulas for the dot product as well as for cross product, or some properties you can say. So properties, first we will see the properties of dot product. So what is the properties of dot product? The properties of dot product is, the properties of dot product is, first property, commutative. It is commutative in nature. It is commutative in nature. Commutative means if I find A dot B, I can say this is equal to B dot A. That is the first thing. Second thing is distributive in nature. Distributive in nature. In nature. What do you mean by distributive in nature? Means suppose I have a suppose I have a dot B plus C. So you can distribute it without any problem. It is A dot B into A dot C. There is no problem. Correct. Next is very important thing, that is a projection of one vector on another. How to find the projection of one vector on another? Simple logic I am giving you. Suppose this is my vector A, this is my vector B, and this is my vector B, this is my vector A first, and suppose this angle is theta. What I want to do, I want to project this vector B on the vector A, and this is going to be my projection. Now a simple question is that how to find this projection. The projection will be simply given as mod of B into cos theta, correct? Now what is cos theta? Cos theta we know that will be A vector dot B vector divided by mod of A vector into mod of B vector, correct? So mod of B will be cancelled out, so you will get A vector dot B vector divided by mod of A vector. That is called as a projection of B vector on A. Projection of B vector on A vector. That is called as a projection of B vector on A vector. Similarly, projection of A vector on B. Similar case, I tell you the direct way to write. Just write the dot product of A dot B. Now on which vector you have to find the projection? Projection on B, na? Just divided with the B vector. Simple. That is the result. That is a trick to directly write the projection of one vector on the. No need to do anything else. Clear? So that is about the properties of dot products. Similarly, we have a properties of cross product also. Okay. Properties of cross product. Now what is the property of cross product? First property, it is non-commutative. Non-commutative means what I am trying to say, A cross B is not equal to B cross A. Then what is the condition? A cross B will be equal to minus times of B cross A. That is a condition. There will be 180-degree sign change, or you can say. Second thing, it is distributive. It is distributive. Okay. It is distributive. It is distributive means if I have a cross B plus C, that can be written as A vector cross with V vector plus A vector cross with C vector. Clear? That is the first thing. Third thing, how to find the A cross B? That is a very important thing. How to find A cross B? So you have to use the determinant rule. What is the determinant rule? Just see here. Write I, J, K. And suppose A vector is AX, AY, AZ, BX, BY, BZ, plus minus plus. Simply what you have to write. See. This is first row, first column. Just cover this and cover this. What you will get is this thing. Just you have to write I, that is AYBZ minus BYAZ. Similarly, you go to minus J. Now, first row, second column. First row, second column. So this is AXBZ minus BXAZ. Okay, next is plus K. Now first row, third column, first row, third column, then we will get AXBY minus BXAY. That is the cross product of a vector. How to write the cross product of a vector? Second thing, remember that A cross B vector magnitude will be equal to B cross A vector. Magnitude will be same. There is no problem with the magnitude. Okay. Second thing, cross product of A cross A will be equal to 0. Why? Because the sine theta will be 0. Because theta is 0 now. Because they are along the same. Because the angle between the same vector, if I am saying what is the angle between with me, 0. Because I am making a 0 angle with myself. So that's why theta is 0. Now some important formulas, that is area of triangle by cross product. They will ask you half. Remember, half into A vector cross B vector. That is the first case. Second is area of parallelogram. They will ask. So for area of parallelogram, remember the formula is two cases, half into cross of mod of A vector cross B vector. That is the first case. That is the first case when you are using this case when it is a diagonal. When it is a diagonal. Second case, this area can be written as mod of A cross B vector when it is side. When it is sides. So this is how we have defined the angle between the two vectors. And one more very important thing is that as in the dot product we have seen, here also you remember this. Let me write it here. Okay. One important thing, remember that I cross I 0, I cross J, J cross J is 0, K cross K is 0. Now you have to remember one cycle, I, J, k, and you have to remember this order. So suppose if I ask you what is I cross j, so it is in the cycle, correct? What is left? K cap. Similarly, if I ask you what is j cross I, see j cross I, but we know I cross j, so k will come, okay, but it is opposite na, so minus sign will be there. Similarly, I can ask you j cross k. Now first you see j cross k, okay, it is in the order j cross k. What is left? I. But if I ask you what is k cross I, k cross I, it is in the order, so it will be j. So like that, you have to see first whether it is order. If it is the order, then normal plus sign. If it is opposite of the order, then minus sign. This is how you find the cross product with I, j, k component. So if we see in the vectors, we have completed everything which is required for solving the questions. First we have started with the basic definition, that is what is the different types of physical quantities, that is scalar quantities and the vector quantities, and then we move toward the physical quantities, and we have seen the important definitions and important points how to represent the vectors. Then we have seen the type of vectors, where one of the important vector is the unit vector, and after that we have seen the some important cases, that is how to add a vector, how to subtract a vector, what are the different law of additions in the vector, some special cases, and then we have see the resolution of the vector, means how to take the component of a vector. Then we have seen the dot product, cross product, and we have seen the different properties. One important thing I will like to tell you in the last, in the vectors, which is always important to remember, it's a type of, you can say, trick. Suppose basically here, if you have seen, whenever someone asks you to find the unit vector, okay, suppose I have a vector A is given as, suppose I cap plus j cap plus k cap. Just what you do, unit vector, just write that vector as it is and divide it with its magnitude. The magnitude of this is root 3. Simple. If you how to find the magnitude, that you know, I have told you the given you the formula 1 square plus 1 square plus 1 square, like that. This will be the magnitude, just divided with this magnitude, it will be the unit vector. Like that you can find the unit vector of any vector. I have given you the formula also, you can see that formula. So in this session we have seen completely the vectors. In the next coming sessions we will now we will proceed in the kinematics part, and we will see the projectile motion and we will see the circular motion. So our two important portions before the first test will be completed, and then we can go for the test, and till then I hope you have understand this session and you have learned some new things. Till then, take care, goodbye, have a nice day. Thank you. Get the mouse. No sir, I need mouse to end the history.